Hello everyone, this is Nagaraju Rebba. Today I am going to discuss a chemical equations lesson. So in this class I am going to discuss the chemical equations. So before I am going to discuss these chemical equations, just I will give some introduction part, which is present on the chemical equations. You know that here the chemical equations. So mostly in this lesson we are discussing only equations. And at the same time here in this class I am saying that, so the first one is called as a physical change. Physical change. And the second one is called as a chemical change. So simply what I am saying that in this class I am discussing only two important terms. One is called as a physical change and second one is called as a chemical change. Why? Because you know that in our surroundings, so simply we are observing these so many chemical reactions. So in that all chemical equations or chemical reactions, so they all contain some different properties. They all contain some different physical and chemical nature. So therefore, so some reactions are just like physical change and some reactions are the chemical change. Which one are the physical change and which one are the chemical changes? Simply I will explain that. So the first one is called as a physical change. So physical change means it is called as a temporary change. Physical change means it is called as a temporary change. Temporary change. Physical change means it is called as a temporary change. And at the same time here you will see this physical change is called as a temporary change. And at the same time, suppose I am saying one example based on this physical change. Suppose you will take, this is called as one of the beaker. So in this beaker you will take the some amount of the water molecule, like this is all nothing but the water molecules. So by the heating of these water molecules, with a closed vessel, this is called as a closed vessel. By the heating of this water molecule with a, what is that, a plate. So what will happen here means, so these water molecules are converting into vapor molecules. These water molecules are converting into a water molecule. These water molecules are converting into vapor molecules, and again these vapor molecules are converting into liquid molecules. So therefore it is called as a temporarily that liquid molecules are converting into vapor molecules. Again that vapor molecules are converting into liquid molecules. So therefore that is called as a temporary change. So generally temporary changes all are under the examples of what is that, the physical change. Physical change. I will say the two or three examples. By the tearing of a paper. By the tearing of a paper, that is also called as a physical change. Why? Because by the tearing of a paper, after that we will join that paper easily. So therefore that is called as a, what is that, temporary change. And at the same time you know that this is also one of the examples for the temporary change. So all temporary change examples are related to the physical change. So finally I am giving you one conclusion regarding these physical change. Physical change means it is nothing but just like a temporary change. By this temporary change, so which material we will take after completing of the reaction also, you will get the same material. So therefore that is called as a physical change or temporary change. And the second one is called as a chemical change. Here you will see chemical change means it is nothing but a permanent change. So chemical change means it is nothing but a permanent change. So permanent change means here you will see, so initially we will take the one substance, after completing of the reaction we will get the different substance. So initially we will take the one substance, suppose you will see, I am writing that here, so carbon burns in the presence of oxygen atom if you produce the carbon dioxide. Carbon burns in the presence of oxygen atom if you produce the carbon dioxide. Here you will see, so initially carbon and oxygen both are the intermixing with each other. Initially carbon and oxygen both are the react with each other. After completing of the reaction we are getting the carbon dioxide. After completing of the reaction we are getting the carbon dioxide. So therefore here you will observe that, so initial substances are completely different of the final products. Initial substances are finally completely different of the final products. So therefore like this type of reactions are called as a chemical changes. So chemical changes means it is nothing but a temporary, permanent change. And at the same time, if you are taking one material, after completing of the reaction, we are not getting same material. So therefore, like the type of examples are called as a chemical changes. Here you will see in the board I written carbon burns in the presence of oxygen atom, it will produce the carbon dioxide. Carbon burns in the presence of oxygen atom, it will produce the carbon dioxide. Here you will see, so carbon and oxygen both are the different materials. Carbon and oxygen both are the different materials. After completing of the reaction, we are getting the carbon dioxide. The carbon dioxide is also called as one of the different material. That carbon dioxide is also called as one of the different material. So therefore, we are writing this one is called as a permanent change. So I will say a few examples based on this permanent change. Here you will see first one is called as the process of digestion. The process of a digestion. So the process of a digestion is called as a chemical change. The process of a digestion is called as a chemical change. Why? Because initially we will take some food material. After completing of the digestion, just like we are getting the different material. So therefore, that is called as the process of digestion is called as a chemical change. And I am writing that one more example here. The process of respiration. So the process of a respiration. So the process of a respiration is also called as a chemical change. The process of a respiration is also called as a chemical change. So why? Because you know that. So respiration means it is nothing but a breathe in and breathe out. So if you breathe in means we will get the oxygen gas, and if you breathe out means we will release the carbon dioxide gas. So breathe in, breathe out, both are called as one of the system in the respiratory process. So therefore, if you breathe in oxygen gas and we will release the carbon dioxide gas. So therefore, this is also called as a permanent change. A permanent change means it is nothing but a chemical change. The respiratory process is also called as a chemical change. The respiratory process is also called as a chemical change. And I am writing that one more example here. So what is that one more example means here? Burning of the crackers. Burning of the crackers. So this is a burning of the crackers. So the burning of the crackers or the burning of the candle, the burning of the incense stick. So whatever you will take, the burning of the paper, the burning of the wood. So whatever you will see. So these are all examples are under the chemical changes only. Why? Because initially we will take the paper. By the burning of the paper, what will happen is finally we will get the ash. So that ash is a completely different of the paper. And at the same time burning of the wood. So wood material is a completely different. After burning of the wood, so which product we will get means just like ash. So that is also completely different. So therefore, what I am saying that here burning of the crackers also called as one of the examples of the chemical change. The burning of the crackers also called as one of the examples of the chemical change. And here you will see I am writing that 2 or 3 examples based on these. Here, which one are the chemical changes here? So next one is here, the burning of the crackers and so lime, so powdered lime. Powdered lime added to water. Powdered lime added to water. See here, powdered lime means lime formula is the CaO. Powdered lime added to a water molecule. Here the powdered lime means it is nothing but a calcium oxide. So this calcium oxide is dissolved into the water molecule. So then it is forming as a CaOH of taken twice. CaOH of taken twice. Initially we are taking this is called as a powdered lime, and this powdered lime is dissolved into the water molecule, and after that we are getting this is called as a calcium hydroxide. Calcium hydroxide. By the observation of this reaction, so initially these two substances are completely different of in the final product. So therefore, this type of a reaction is also called as chemical changes. Chemical changes. And the next example I am saying that here, so exposing the iron nails. Exposing the iron nails in a atmosphere, moisture. In an atmosphere, what will happen? Just like if you take the iron nails, so that iron nails are react with the atmospheric moisture, so then that iron nails are getting as a rust. That iron nails are rusting as a gas. That iron nails are getting as a rust. So therefore, that is also one of the examples of the chemical change. So the rusting of the iron is also called as a chemical change. Like that, here you will see. So what I am saying that in this class, physical changes and chemical changes. By the observation of the physical changes, generally physical changes are called as a temporary changes. If one reaction is going on, so initially which substance we will take, after completing of the reaction also we will get the same material. So therefore, the type of reactions are called as the physical reactions or physical changes. I am saying that generally physical changes are called as the temporary changes, And suppose this is called as one of the beaker. In this beaker I taken as some amount of the water molecule. By the heating of that beaker, what will happen is the liquid molecules are converted into vapor molecules. So this is called as a closed vessel. By the closed vessel, what will happen is these vapor molecules are bombarded into the wall of the container, like a plate of the container, and after that liquid, yes, vapor molecules are again converting into liquid molecules. So therefore here, initially we take it as a liquid molecules. After completing of the reaction also, we will get the same liquid molecules. So therefore this is called as a physical change. This is called as a physical change. And the second one is called as a chemical changes. So generally chemical changes are called as a permanent changes. Chemical reactions are called as a permanent reactions. And at the same time, what I am saying that these are permanent reactions are, I said that many examples are here. The process of the digestion. The process of the digestion is called as a chemical change. Why? Because initially we will take some fruit material after completing of the reaction. So finally we will get a different material. So therefore the process of the digestion is also called as a chemical change. So means initially we will take the one material, after completing of the reaction we will get the different materials. Therefore that is called as a chemical change. By the observation of the second example here, the process of the respiration. The process of the respiration. Generally, in the respiratory process, so what will happen is breathe in and breathe out. So generally, human beings are breathe in oxygen gas and breathe out carbon dioxide gas. By the breathe in, we will get the oxygen gas. By the breathe out, we will release the carbon dioxide gas. So therefore, the respiratory process is also called as a chemical change. And the next one is called as the burning of the crackers. Burning of the paper, burning of the wood material, and burning of the incense stick, whatever it is. So by the observation of these all examples are under the chemical changes only. Why? Because if suppose you will see, so the burning of the just like paper. So initially paper is called as one of the material. After burning of the paper, you will get the ash. That ash is a completely different of the initial material. So therefore that is called as one of the different form. And at the same time, if you take the incense stick, so by the burning of the incense stick, finally we will get the ash. So the ash is also called as a completely different product. So therefore, like this type of examples are called as chemical changes. Like this type of examples are called as chemical changes. And powdered lime added to a water molecule. Powdered lime added to a water molecule. So here you will see powdered lime means it is nothing but a calcium oxide. Powdered lime means it is called as a calcium oxide. This calcium oxide is dissolved into the water molecule, and then it is forming as a calcium hydroxide. This calcium hydroxide is also called as one of the completely different product when compared with the initial reactants. So therefore here, so like this type of all examples, like exposing of iron nails to the moisture. Generally, you know that if you take any iron material, you will keep into the outside, and that iron material is react with atmospheric moisture, and then it is getting as a rusting. That rusting is also called as a permanent change. So therefore, that is called as our chemical change. So these two important chemical changes are always permanent changes, and the physical changes are always temporary changes. So therefore, this is called as a brief introduction about general introduction of the chemical equations. And then I am saying that here, based on these reactions, I will say the three important activities. So three important activities. Here I am saying the first activity here. Activity 1 here. So what is the activity here? Activity 1 here means first you will take just like 1 gram of see here, first activity, here you will take 1 gram of a calcium oxide, 1 gram of a calcium oxide. This calcium oxide another name is called as a quicklime. The calcium oxide another name is called as a quicklime. 1 gram of a quicklime react with 10 ml of a water molecule. 10 ml of a water molecule. So then what will happen here you will see. So suppose I am taking, this is called as one of the beaker. So in this beaker I am taking 10 ml of the water molecule. So this is called as a 10 ml of the water molecule. So in this 10 ml of a water molecule, we will have only 1 gram of a calcium oxide. 1 gram of a calcium oxide, like by the adding of the 1 gram of a quicklime. So this is called as a quicklime. What will happen is simply you will see, by the touching of the beaker, what we will get is, so generally calcium oxide is dissolved into the water molecule. It is dissolved into the water molecule, and it will produce the heat energy. When you touch the walls of the beaker, so what will happen is just like we are getting the heat energy. When you touch the walls of the beaker, we will get the heat energy. So therefore, you can observe that by the reacting of the calcium oxide with the water molecule, it will release the heat energy. Means it will liberate the heat energy. Liberated heat energy. So what happened in the first activity means 1 gram of a quicklime react with or 1 gram of a quicklime is dissolved in the 10 ml of a water molecule. 1 gram of a quicklime is dissolved into the 10 ml of a water molecule. So after that you will see, just like if you touch the beaker, so what will happen is just like the beaker will produce the heat energy. Here calcium oxide is react with water molecule and it will liberate the heat energy. It will liberate the heat energy. By the liberation of that heat energy is called as simply this is called as exothermic reaction. Exothermic reaction. So when the material is released the heat energy, when the material is released the heat energy, so therefore it is indicating as an exothermic reaction. When the material is releasing the heat energy, so therefore it is indicating as an exothermic reaction. So therefore in the first activity, so if you take the calcium oxide, the calcium oxide is dissolved into the 10 ml of the water molecule and then so it will produce the heat energy. How we will see, how we will identify the reaction is producing the heat energy means by the touching of the walls of the beaker, it will produce the heat energy. So therefore we will identify that. So the given one is called as an exothermic reaction. The given one is called as an exothermic reaction. So simply I am writing that here you will see calcium oxide, this is called as a quicklime. So this quicklime is reacting with the water molecule and then it is producing as a calcium hydroxide. CaOH of taken twice plus here simply we are writing this is called as a heat energy. So here the plus heat energy is indicating as a exothermic reaction. Plus heat energy is indicating as a exothermic reaction. So therefore this is also called as a very important in our activity. And I am going to discuss the second activity here. Second activity in our textbook. What is that second activity means? Suppose you will take, this is called as one of the beaker. In this beaker you will take the 100 ml of the water molecule. So this is called as one of the beaker. So in this beaker we will take that just like 100 ml of the water molecule. 100 ml of water molecule. In this 100 ml of the water molecule, if you add the very little amount of yes, what is that? Sodium sulfate. A little amount of a sodium sulfate. Sodium sulfate formula is Na2SO4. Sodium sulfate formula is Na2SO4. What I am saying that here, so this is called as one of the beaker. In this beaker I am taking as a 100 ml of the water molecule. In that 100 ml of the water molecule I will add the small quantity of sodium sulfate solution and then this is called as a aqueous sodium sulfate solution. Here this is called as adding of the Na2SO4 solution. Therefore this one is called as aqueous Na2SO4. These aqueous Na2SO4, the color of the aqueous Na2SO4 solution is white in color. The color of the aqueous Na2SO4 solution is called as white in color. And at the same time, another beaker you will take so in the other beaker you will take the 100 ml of the water molecule. 100 ml of the water molecules here. In this 100 ml of water molecules, you will add a very little amount of here barium chloride. A little amount of barium chloride. So what I am saying that this is also called as one of the beaker. In this beaker you will take the 100 ml of water molecule, 100 ml of water molecule, and in this 100 ml of water molecule, if you add a little bit amount of a barium chloride, and then this is called as an aqueous solution of a barium chloride. Aqueous solution of a barium chloride. Here the barium chloride color is called as white in color. Here also the barium chloride color is called as white in color. And then you will see here Na2SO4. This Na2SO4 is react with the barium chloride. Barium chloride solution. Then it is forming as a barium sulfate. BaSO4 plus here it is forming as a 2 moles of NaCl. It is forming as a 2 moles of NaCl. See here once again I am writing that here. Based on this reaction, so what I am saying that here, Na2SO4 is called as sodium sulfate. This sodium sulfate is react with the barium chloride, aqueous barium chloride. So what will happen here means it is forming as a barium sulfate. BaSO4 plus 2 moles of NaCl is formed. Here the barium sulfate is forming as a precipitate. The barium sulfate is forming as a precipitate. In this, the downward arrow mark is indicating as a precipitate. The downward arrow mark is indicating as a precipitate, and at the same time here you will see this is called as a white color, and this is also called as a white color, and by the resulting of this end product, this one is also called as a white in color. That one is also called as a white in color. So therefore, this is called as a second activity. So what I am saying that once again I am saying the second activity. Here you will see in the first I am taking one of the beaker. In that beaker I take as a 100 ml of the water molecule. In that 100 ml of a water molecule I added as a little amount of a sodium sulfate. Here the sodium sulfate color is called as a white in color, and then this is called as aqueous sodium sulfate solution. And again I am taking the one more beaker. In that beaker also I am taking the 100 ml of the water molecule. In that 100 ml of a water molecule I added as a little bit amount of a barium chloride, and then here the barium chloride color is called as a white in color. By that this is also called as a aqueous barium chloride sulfate solution. And both solutions, by the mixing of the both these solutions, here this is called as a aqueous sodium sulfate solution, and this is also called as a aqueous barium chloride solution, and finally the resultant product is called as a barium sulfate. The resultant solution is called as a barium sulfate. So this barium sulfate is forming as a precipitate. So that precipitate is not dissolved in the water molecule. That precipitate is undissolved into the water molecule, and it is also showing as a white in color, and therefore 2 moles of the sodium chloride is dissolved from here. And then next I am going to discuss the third activity. By the observation of the third activity, suppose this is called as one of the conical flask or one of the beaker. In this beaker I am taking a very few amount of zinc granules. So zinc is called as a formula general. Zinc granules is nothing but zinc metals. So just like I taken as a one beaker, conical flask. In that conical flask means like this is called as a conical flask. Like this one is called as a conical flask. In that conical flask I taken as a some amount of the zinc granules. In that zinc granules I will add 2 or 3 ml of hydrochloric acid. 2 or 3 ml of hydrochloric acid, like this is called as a hydrochloric acid. By the adding of the lower amount of the hydrochloric acid. So what will happen means here you will see simply it is forming as a ZnCl2 plus here the hydrogen gas is liberated. By the reacting of the zinc metal to acid. See here, so first I am taken as a zinc metals, and in this zinc metals I added as a 2 or 5 ml of hydrochloric acid. So what will happen means it is react with the hydrochloric acid, it is producing as a zinc chloride and hydrogen gas is liberated. Zinc chloride and hydrogen gas is liberated. Here the upward arrow mark, this upward arrow mark is indicating as a liberation of a gas. Liberation of a gas. The upward arrow mark is indicating as liberation of a gas. And see here, so how we will identify the given one is called as the releasing one is called as a hydrogen gas. How we will identify the given one? Yes, the releasing one is called as a hydrogen gas. Means if you keep here burning matchstick, so when the producing of the hydrogen gas, when the hydrogen gas is attached with the burning matchstick, if the hydrogen gas is attached with the burning matchstick, immediately it will produce the pop sound. And immediately that is a put off. Immediately it will produce the pop sound and it is immediately put off. That is called as one of the identification of the hydrogen gas. So what I am saying that in this activity, so 2 or 3 pieces of a zinc metals react with the hydrochloric acid. Here it is forming as a ZnCl2 plus hydrogen gas is released. The given one is called as a hydrogen gas or not. How we will identify it means if you keep here the burning matchstick. Immediately when the hydrogen gas is attached with the burning matchstick, react with the burning matchstick, immediately this burning matchstick is it will produce the pop sound. And immediately it is a put off. That is called as a symbolical representation of identification of the hydrogen gas. If in case here the releasing one is called as a carbon dioxide gas. In that particular case, if you keep here burning matchstick, what will happen means immediately it will put off. But it doesn't produce any sound. So therefore, the coming one is called as a carbon dioxide gas. Here just like I am saying two gases, one is called as a oxygen gas, hydrogen gas, and the second one is called as a carbon dioxide gas, and the third one is called as a oxygen gas. If in case the producing one is called as a oxygen gas, if you keep here the burning matchstick, it is producing as a just like brightness. It is burning with brightness. So why? Because oxygen gas is very important for the burning of any material. So therefore, if in case that oxygen gas will produce immediately it will produce the brightness. If in case here the hydrogen gas is a producer, immediately this burning matchstick is put off with pop sound, and at the same time immediately it is put off. If in case the coming one is called as a carbon dioxide gas, immediately the burning matchstick is put off. There is no sound. So therefore, these three activities are very very important in our equations. And at the same time, here I am saying that the chemical equations. So what is the chemical equations? Main I am saying that you know that in our surrounding we are seeing so many chemical reactions are there. In that all chemical reactions, if you take one chemical reaction, definitely that chemical reaction contains the two important terms. In our surroundings, we are observing that so many chemical reactions are there. In that all chemical reactions, so compulsory every chemical reaction contains two important terms. One is called as a reactants, and the second one is called as a products. If you see any chemical reaction, that chemical reaction contains two important terms. One is called as a reactants, and the second one is called as a products. Here you will see I am saying the definition of the reactants. The chemical substance which is react with the, so the chemical substances which are react with each other, which are react with each other in initial state. Initial state is called the reactants. See here, very important. The chemical substances which are react with each other. The chemical substances which are react with each other initially. The chemical substances we are react with each other initially. So therefore they are all called as reactants. Here you will see carbon burns in the base of oxygen atom. It will produce the carbon dioxide. Carbon burns in the base of oxygen atom. It will produce the carbon dioxide. See here. So this is called as the initial state of the reaction. So in the initial state of the reaction, carbon is called as a solid material. Carbon is called as a solid material, and oxygen is called as a gaseous material. And here the carbon dioxide is also called as a gaseous material. See here, carbon burns oxygen atom, it will produce the carbon dioxide. So initially only these two reactants are participated. So which one are the initially participating substances? See here. So the chemical substances which are participating in the initially the reaction. The chemical substances which are participating initially in the chemical reaction. So therefore they are all called as the reactants. Here just like by the observation of this reaction, carbon burns in the base of oxygen atom, it will produce the carbon dioxide. Initially carbon is a bond with oxygen atom. So therefore, these two are participating in the initially. So therefore these two are called as the reactants. And finally I am saying that which one are participating in the chemical reaction initially. So therefore they are all called as a initial means they are all called as the reactants. And at the same time, so simply what I am saying that which materials are starting materials in the reaction. Which materials are starting materials in the reaction? That the starting materials are called as the reactants. And the next one is called as the products. So products means after completing of a chemical reaction. After completing of a chemical reaction, which substances are formed? Which substances are formed after completing of the chemical reaction? Which substances are formed are called products. After completing of the chemical reaction, which substances are formed are called products. Simply I am writing the one equation based on these. Suppose you will see here, magnesium burns in the presence of oxygen atom, it will produce the MgO. So here you will see magnesium burn in the presence of oxygen atom, it will produce the MgO. So this is called as a arrow mark. So by the this is called as a head of the arrow mark. So these head of the arrow marks move towards the completion of the reaction. These head of the arrow mark is indicating as a move towards the end of the chemical reaction. So therefore, this is called as a reactants. After completing of the reaction, we are getting the another product. That another product is a completely different of the reactants. That another product is a completely different of the reactants. So therefore, this one is called as a products. This one is called as a products. Here, what I am saying that after completing of the chemical reaction, which substances are formed are called as a products. Here, after completing of the reaction, we are getting this is called as a product. And here I am saying very important point. This is called as a arrow mark. Head of the arrow mark is indicating as a move towards the completion of the reaction. The head of the arrow mark is indicating as a move towards the completion of the reaction. Here this is called as the initial. So arrow mark, left hand side, this is called as the left of the arrow mark, and this one is called as the right of the arrow mark. So in this arrow mark, left hand side, always you must write the reactants. Left side of the arrow mark, always you must write the reactants, and the right hand side of the arrow mark, always you must write the products. Sometimes we are writing that two or more reactants. In that particular case, that two reactants, in between the two reactants, compulsory you must write the positive sign. Here you will see this equation, two reactants are there. In these two reactants, compulsory you must keep the positive sign. That positive sign is indicating as a reacting of the two reactants. So compulsory, reaction, sometimes two or more reactants are react with each other, and it will producing as two or more products. In that particular case, compulsory you must write in that two reactants, compulsory you must mention the positive sign. But that positive sign is indicating as just like addition of the two reactants. So therefore, this is called as so what I am saying that reactants and products. If you take any chemical reaction, definitely, so it compulsory contains the two important terms. One is called as the reactants, and the other one is called as a products. One is called as the reactants, and the other one is called as the products. Here you will see I am writing some word equations. Some word equations based on the previous activities. Suppose you will see the first activity. So what is going on in the first activity means calcium means a quicklime. Quicklime is a react with quicklime is nothing but a calcium oxide. Calcium oxide. So this calcium oxide is dissolved into the water molecule, and it is producing as a calcium hydroxide. Calcium hydroxide. Calcium hydroxide. See here. So calcium oxide, this is called as a word form of calcium hydroxide. Calcium oxide. Word form of the calcium oxide is calcium oxide. What is the formula of the calcium oxide means simply we are writing that the symbolical representation is the CaO. So this is called as the symbolical representation of the calcium oxide, and this one is called as the word formation of the calcium oxide. Word formation of the calcium oxide. Here this calcium oxide is reacting with the water molecule. Water molecule symbolical representation is the H2O. Then both are the react with each other, and then we are getting CaOH of taken twice. So this is called as what is that symbolical representation of the calcium hydroxide? So this is called as the word formation of the chemical reaction. So in the above one, this one is called as the word formation of the chemical reaction. Based on that word formation, I written as a symbolical representation. So therefore, this is called as the word formation and symbolical representation of the equation. And at the same time, you will see second equation. So second activity. In that second activity also, we written just like sodium sulfate. Word formation I am writing that sodium sulfate. Sodium sulfate react with the barium chloride. Barium chloride, it will produce the barium sulfate. Barium sulfate plus sodium chloride. Barium chloride plus barium sulfate plus sodium chloride. See here, sodium sulfate. So this is called as the word formation of the sodium sulfate. But what is the formula of the sodium sulfate? Is Na2SO4. this is called as a symbolical representation or simply chemical formula. And next barium chloride, this is called as a word formation. In this word formation I am writing as a symbolical representation barium chloride. And then here you will see, so barium sulfate, BaSO4 is called as a symbolical representation of the barium sulfate. Let's see here the 2 moles of the sodium chloride is formed. 2 moles of the sodium chloride is formed. This is called as a word equation as well as a symbolical representation of that respect to chemical equation. Word equation as well as a symbolical representation. See here, these two are acting as a reactants. This is the arrow mark, and the arrow mark left hand side, always you must write reactants, and this is called as arrow mark right hand side, always you must write products. Here you will see these two are the 2 reactants. In between the 2 reactants, compulsory you must mention the positive sign. In between the 2 reactants, compulsory you must mention the positive sign. And here also in between the 2 reactants, compulsory you must mention the positive sign. That's a very, very important. And last equation I am writing that here. So zinc granules react with the hydrochloric acid. Zinc granules react with the hydrochloric acid. It is producing as a zinc chloride. Zinc chloride plus hydrogen gas is liberated. Zinc chloride plus hydrogen gas is liberated. Here also by the observation of 2 reactants are there. By these 2 reactants, compulsory you must mention the positive sign. And here are 2 products are there. Compulsory in these 2 products also we must mention the positive sign. So therefore this is called as a word equation as well as a symbolical representation of the respect to chemical equation. So therefore this is called as one of the introduction part, and as well as what are the main activities are present on the chemical equation. And at the same time, so which one is called as a what is that chemical change, and which one is called as a physical change, and which one is called as a reactants, and which one is called as a products. And I am saying that very important point. So what is that? A very important point is exothermic reaction. Here I am saying that one more is called as the endothermic reaction. Endothermic reaction. Endothermic reaction is very, very important. So suppose if the reaction is going on, so compulsory it will need the some amount of the heat energy. Compulsory it will need the some amount of the heat energy. So therefore, so by the absorption of heat energy, absorption of heat energy is called absorption of heat energy is called as endothermic reaction. Absorption of heat energy is called as endothermic reaction. Suppose you will see, so with respect to sunrise, so just like human beings and animals and plants, with respect to sunrise, human beings, plants and animals, just like human beings, plants and animals will absorb the heat energy from the sunrise. So therefore, with respect to sunrises, just like human beings and plants and animals are acting as a what is that endothermic reaction. And action exothermic reaction. So exothermic means it is nothing but a releasing of heat energy. Releasing of heat energy. So releasing of heat energy means with respect to sunrises, sun is releasing the heat energy. Therefore, the sun is acting as an exothermic. So therefore here exothermic means releasing of heat energy. Endothermic means it is nothing but absorption of heat energy. Exothermic means it is nothing but releasing of heat energy, and endothermic means it is nothing but absorption of heat energy. So therefore this is called as the 2 types of reactions. So this is the introduction part of in our chemical equations, and remaining topics I will discuss with you in our next class. Thank you very much.